Okay, hi, we're going to talk very quickly about how it is that I graph a system of linear equalities. So basically what I'm doing here is that a system is when I ever take more than one linear equation and I put it all onto one graph, and what I'm looking for is where do my two lines intersect, and the reason I'm looking for that is because I'm looking for the very specific x and very specific y that is the same x and y down here that will make my equations both have true statements. So what I'm looking for is what point on both of my lines, graphically, do both my lines go through, and in that case, because these are linear equations, that they're going to be where they intersect, and at that intersection, that is the absolute x and y coordinate pair that if I plug into both these equations will make true statements, and I'll show all this. So here we go. First things first is what I have to notice is that these are in x and y are on the same side, and they are not in graphing form for us to do it by hand. If I wanted to, I could make t-tables, plug numbers in, and get an answer, but for me, I just want to simply go through this problem, put it in y equals mx plus b, so I can quickly go through and graph it by hand. So here we go. I'm going to talk about it out loud as how I would do it. So the first thing I would do is in the first equation, it says negative x plus 3y equals 6. So the first thing I would do is I would add this x to the opposite side, because values and terms that are on one side, they are the opposite value on the other side. So if it's negative on the left, then it should be positive on the right. So what that allows me to do is that 3y is then equivalent to x plus 6. The last thing I would then do is I would divide by 3, and I would divide every single term by 3. And what that creates is then y is going to be equal to 1/3 x plus 2. Okay? So I would do the same exact thing for the one down below. I would add the x, and I would get negative y. So the important thing is that you keep this negative with it. Negative y equals x plus 2, and I would divide by negative 1. So that would give me y is equal to negative x minus 2. Okay? So now that I have them in y equals mx plus b form, what I'm going to do is I'm going to go ahead and graph these. So here we go. Y equals mx plus b. This value here, the plus b, which is a positive 2, represents my y-intercept, so I'm going to plug a point there. So the point that I plug in is at positive 2, and at that positive 2, I am then going to utilize my slope, which is up 1 over 3. So if I take a look at this positive, it's up and then over. So up 1 over 1, 2, 3. So put another point. And I'm just going to pick another one to show you that I didn't have to go up and then to the right, because up is positive and to the right is positive. I could also have the combination of negative over negative, which is still a positive ratio. So I could go down 1 over 1, 2, 3. So I could have also had a point that was right here. So I'm going to go ahead and draw this line through. So there's my line, so graphically. So then I'm going to go now to the new line here, which is y equals negative x minus 2. So negative x minus 2. So go to negative 2, put my point, I go up 1 over 1. So there's a point. I'm going to keep going, okay, until I'm going to keep using this line as my slope until I run into my other line. So up 1 over 1, up 1 over 1. So what I have there is I've now got my line. And what I want you to notice here is that when I'm drawing it through, my lines, they intersect at this point right here. Okay, so the one that I've circled here, they intersect. And what I'm going to find there is that the coordinate pair is negative 3 up 1. So it's negative 3, 1. So this point where they intersect is negative 3, 1. So what I now can show you here is that, yes, if I plug these coordinate pairs into this, that it's going to make a true statement. So I'm going to show you that over here just to check that I've done this correctly. So if I take negative 3 and plug it in for x, so the opposite of negative 3, okay, the opposite of negative 3 is 3. Well, 3 plus 3 times 1 is 3, so 3 plus 3 is 6. So that one's good. Then I take a look at here. The opposite of 3 again, the opposite of 3 in this case is 3. So 3 minus 1, well 3 minus 1 is 2. And what you have there is that this is the coordinate pair where they have the x and they share the same x and y for this equation. So I hope that helps for solving systems of linear equalities. And remember, for systems of linear equalities, you're finding out where it is that those two very specific lines cross. So I hope that helps.